Well, good morning, everyone. Welcome to C&E Sales Monthly Webinar Series. I'm Jeff Butler, the Technical Manager here. Today's webinar is titled, How to Securely Integrate Your Machine Network into Your Plant Network. Our presenter today is Jeff Weaver, an automation specialist here at C&E. Jeff's been with us for 10 years. He holds a BSWET from the University of Cincinnati. He spent his entire career in the field of industrial automation. He's also certified in the following areas: Siemens Automation, CompTIA Network Plus, Siemens Switching and Routing, and he's Profinet certified. So I think you're going to get a lot of good information today. Just a few housekeeping items before we start. If you have questions during the webinar, please submit them using the control panel tool on the right side of your screen, and we'll address those at the end of the session. If you don't see that tool, click on the red horizontal arrow and it'll open up that box. Everyone registered for the webinar today will receive a link to recording of it. And that way you don't necessarily have to take notes throughout this. If you're not in a position to do that, you'll be able to review it at a later time. Please be sure to attend next month's webinar. It'll be hosted by Brad Hart of C&E Sales. His topic will be simple sensor replacement. And that topic will cover how IO-Link can be used to do simple sensor replacement. It's hosted on April 12th at 10:30. I will now turn today's webinar over to Jeff.
Good morning. This is Jeff Weaver, Automation Specialist for C&E Sales, the Ohio Territory in Northern Kentucky. And as Jeff mentioned, we're going to talk about how to securely integrate our machine network into our plant network. We've really been doing this for years, just not so much with a mind or an eye towards a secure integration. So we're going to talk about that approach today, or an approach that opens the door for security, and then look at simple implementation. C&E, we specialize in several areas: sensing, safety, vision, motion, automation, controls. We have specialists in each of these areas. If you do have an application that touches an area, please feel free to contact your C&E sales account manager. As Jeff mentioned, several upcoming events, next month's webinar, as well as there's a Profinet one-day class in April. Very handy, taught by PI North America. So with that, we'll jump right in. I'm going to cover a little bit of where we sit today with security, specifically with an eye towards industrial automation. And then what we're going to do is a basic approach to start our security and securing our machine cells. So what are some of the trends that are impacting us? Well, cloud computing, which would certainly fall under the umbrella of Industry 4.0 or IIoT. So the goal to get everything connected and get everything connected to the cloud also increases our exposure. Increased use of mobile devices. So throughout our plants, we have mobile access now to machines. We wouldn't have thought of that even 5 or 10 years ago. Wireless technology is prolific throughout the industry now. Where do we fail? Well, that first one is probably the biggest, the employee, and that is just a lack of control over how we authenticate and get to our systems. Passwords, usernames, simple things like that. But any of these points can fail. Your PC workstations, smartphone access, laptops, all of those things. Policies and guidelines, that's an area where we're just going to reference it today, but that's an area that throughout the industry we really have to grow. The trend that's really getting us is we want everything connected. Horizontally, meaning the machine cell, maybe even machines to machines, and then vertically we want to get that up to data, whether that's SQL Server or cloud-based, or even just office access or plant access. That's the trend, and it's provided way more productivity, much more efficiency, but at the same time, it's exposed us to greater risk. Simple methods that we want to guard, just like we would for IT networks at this point. Social engineering, eavesdropping. Those are pretty simple methods. Access. That's what the intruder's trying to gain, access to a secure network. And I'll show a little example of how we could access a PLC with a simple free download, a tool It's a port scanner that would allow us to go see a PLC, and I'll show you the results that I can get from looking at a non-protected network and how easy it would be for someone to maliciously begin modifying my PLC. And that's where we need to be focused, because the current trend is moving away from just hackers, so to speak, and those skill sets are combining now, where people who have knowledge of industrial control systems are also able to hack into our control systems. So how do they do it? Well, they're going to use some very standard free tools. They can go out and find IP addresses, MAC addresses, even device types. As much as the device itself will even help them out in providing part numbers. So it's pretty easy, actually, to start doing some of these things. Now, this slide is just a little bit old, and the ICS CERT reported 198 attacks that they analyzed back in 2011 to 2012. In 2015, that number was up to 295, and I'm sure today it's higher than that. The point is, though, those are only the reported attacks. So we're seeing industrial control systems being hit. A lot of those are not being reported, and that's enough for us to start preparing. As far as what it can do to us, loss of intellectual property for sure, recipe operations, pretty common. I think our biggest concern would probably be plant downtime. Obviously, when we lose access to office equipment for seconds or even minutes, it may not be a big impact, but when we lose access across a machine for more than milliseconds, we could have a very significant impact. What are the top threats? Well, I think that number one might be the biggest, and we're proponents at C&E of remote access. It's a tremendous savings and tremendous capability, but that use of remote access is something we have to do a little better job of monitoring. The case in point I always make is the end user that's got multiple machine OEMs accessing his or her facility. How do we regulate when that machine OEM loses an employee? How do we make sure that those folks do not have continued access to the machines when they're not even with that OEM any longer? So there's some things that we need to do policy-wise to help protect. This is a story I like to mention. We think anything that is connected to the internet is at risk, and that is true. This is a little machine network that was in a chemical engineering facility, had multiple PLCs and 3 SCADA systems, or data monitoring systems. The data monitoring systems were Windows XP based. It was connected to an Ethernet based network, but was not connected to the internet in any way. All 3 machines went down with the WannaCry, what sounds like the WannaCry virus, some sort of ransomware. And the culprit of all things was an automated coffee machine. The installer of the coffee machine connected to the local network, the local being the machine network, but he did not have internet access, so he then chose to use the plant Wi-Fi for internet access, and that created the path to the SCADAs. All 3 machines went down, as well as the coffee machine. So it's just a kind of a funny story, but just a realistic story to show how quickly something can be attacked once there's any access at all given. So what is the approach? Well, Defenseindepth is an approach both for IT-based as well as ICS, industrial control systems-based networks. Excuse me, also known as the castle approach. The idea is we're going to create independent layers of security, as many as possible. And I would stress, nothing is ever completely secure. We have to know that going in, but we can make it far more secure. And with so many systems that are easy to get to, anything that we secure is unlikely to be accessed or breached. The standards, ISA 99, IEC 62443, essentially these are the umbrella standards that allow us to have different procedures defined for how we're going to implement different security practices and designs. Siemens approach for Defenseindepth, we summarize it to 3 basic areas: plant security, network security, and system integrity. The one we're going to focus on today is network security, which is that middle layer there, the green layer. The plant security That's your physical access prevention, and that really is going to involve to some extent, some social engineering as well. The network security we're going to focus on a bit today, and then the system integrity is down at the machine level, and that would involve things like know-how protection or copy protection within our blocks, our PLC blocks, protection even between the HMI and the PLC, so somebody couldn't access the plant even remotely with an HMI that could then access the PLC. So we're going to be doing, that level is capable, but we're not going to cover that today so much. Some of the areas within Defenseindepth that you would utilize, some of these do not apply or not consistently would apply to an industrial control system, but certainly antivirus software on anything that's PC-based, potentially multi-factor authentication, physical security, DMZs. We certainly can get into DMZs, and a demilitarized zone is essentially just establishing sort of a safe zone that is sitting between two firewalls so that the equipment in a DMZ does not have access without proceeding through a firewall to the control system. It also doesn't have access to the internet without a firewall. Past methods. So these are the methods that we've most commonly used for implementing an Ethernet-based machine to a plant network. And I've done a lot of these, and initially our only goal really was connectivity. So the first approach, and probably the most common, is to simply, okay, I've got a new machine, a handful of Ethernet devices. Initially when we did these, it was just the PLCs that had Ethernet. Now all the field buses are essentially moved into an Ethernet-based field bus. So now all of these devices would be connected up to a plant switch. So this was what we would call a flat network. And in flat means everybody can see everybody. And we would just connect up to a plant switch. It was pretty inexpensive, and we had connectivity. The next layer to that, and I've done this one also, is when we would have within the plant switch a VLAN or a virtual LAN. So that if I have, maybe a plant switch has 24 ports, I might have 12 different VLANs in that switch. And now if my machine's connected to, say, port 4 and part of VLAN 10, then I'm on another side of the facility connected to a switch that's also at that physical connection, a member of VLAN 10. I can access that, but only members of VLAN 10 could access that machine. So that's another approach that's basically an expansion on just the plant network connectivity. And that approach works and does provide some level of security. Third approach I've seen pretty commonly is to simply add another Ethernet module to the PLC. Now this adds some expense, but this would be to simply put an Ethernet module in the PLC. Now I can access that PLC via that Ethernet connection, and but it still requires potentially or likely a plant network drop. So again, the first method from the flat network has grown into the other two methods. So this is what that might look like. So here I have a PLC, an HMI, drive, 3 nodes of I/O, distributed I/O, and then I have a switch that is managed or unmanaged, could be either, connected up to a plant switch, and then here's my PC sitting out in somewhere on the network, and I'm accessing all of these machines. And notice they're all taking addresses, 10.19 addresses in this case, on the plant network. So all of these addresses are being reserved. So this is not a large machine. So a larger machine, I might have 40 or 50 nodes. Now I'm really chewing up some IP. It really starts to make this approach pretty inconvenient and short-lived. So another approach then is to VLAN it. So now this VLAN exists, and I could be connected to other machines out of this same switch, and those machines and that traffic would not interfere with one another. It provides some level of broadcast mitigation, and it also provides some level of security. So what are the pros and cons of these approaches? Well, the pro with a flat network is it's the simplest solution, and every device is accessible. What's the con with the flat network, just a plant network drop? Well, the con is that all devices are accessible. Additionally, we utilize a lot of IP addresses, and then of course the topic for the day, there's no security on that approach, and potentially no determinism for the automation network. What do I mean by that? Determinism is essentially how dedicated is the process, so to speak. So if the PLC is communicating with the I/O nodes, we want that traffic to be totally dedicated to that node, and we want the switch that it's running through to understand that that traffic is our top priority. Well, when we connect up to a plant network, that may not be the case. We might get, our network might get drained by some voice over IP traffic. So the next approach was adding a VLAN. That mitigates some of that. So the VLAN does create a more deterministic automation network. The con is that the configuration of the VLAN is required, and that's typically done by someone in IT. So it makes it a little more difficult for the automation professional to have control of how his machines are going to communicate and how he's going to communicate with the machines. Additionally, if you're across a plant, you may be adding another layer of configuration routing between VLANs. So you may be on VLAN 4 and your machine's on VLAN 10, so there are rules to be set up. And then every time you add machines or even relocate within the facility, you may have to modify those rules. It does provide some determinism. It does not provide a true firewall. Third approach, adding an Ethernet module to the PLC, it does create a single IP address for PLC access. And now without PLC software, it's unlikely that our PLC could be essentially hacked or modified. That's a pro. The con here is that it typically does not provide access to the HMI. We could put the HMI over on that network, but usually that doesn't happen. Also, not every PLC, and this is the biggie, supports this approach. So if I had a SLC 505, I can't do this. But I can with several PLCs, but not every PLC. So I don't have a way, if I use this approach, to just slap in a machine to the network securely using this approach. So it's not going to give me a standard approach from machine to machine. And of course, security is typically not included. That's not always the case. Siemens has several Ethernet-based communication processors that install on the chassis that are secured, such that you could turn on firewall. So that is possible, but that's not common across the industry. So how would we do this? Just the first step, how would we do this today? A little better. And that is, instead of connecting directly to my plant switch, I connect through this security device. And at this point, all I'm having this device do is provide a function called NAT, naming address translation, or network address translation. I'll explain that in a moment. So what that would allow me to do is pick and choose which devices were going to be visible up on the plant side of the network. So here's the address, this NAT IP. So I take this initial address of the PLC, which is 192.168.0.5, and I'm going to bring it up to the plant network. So by creating a NAT address, that IP address for the PLC now looks like 10.19.50.105 to my PC. That NATing is taking place in the NAT device, which is, in this case, this S615. I also pointed out that I could do the same thing for my HMI. I might do that if I wanted to download to the HMI, or if I simply wanted to see the web server on the HMI, which is, of course, very common. So this would allow me from machine to machine. Maybe an HMI does not have a web server, but this would still allow me to plug this device in to, for instance, an old SLC 505, and take that SLC's address and NAT it up here to this upper level, and that gives me some security, or at least isolation. We haven't gotten to actual security yet, but at least we could put the SLC up on the plant level network. So what is NAT? Network address translation means basically that we're going to take an IP address on one network and translate it into a different IP on a different network. And by network, I mean subnet. And typically that's a different physical network as well. So here we have a static NAT, which is a one-to-one, similar to what I just illustrated, where my 192.168.0.5 became 10.19.50.105. We have dynamic IP, or dynamic NATing, and that's not something we're probably going to do in an automation network. And then we have port address translation, also known as masquerading or network address port translation. So that's something you do at home every day without thinking about it. So with port address translation, what's typically happening, you have multiple private IP addresses running through a NAT device, which would be your home router. And say I want to go access Google at port 443. The router is then going to take my IP address, turn it into the router's NAT address, the router's IP, and then assign me a different port. Send it on to Google. When it receives that message back, it manages where it needs to go and sends it back to my PC. That's not typically what we're going to do in an automation network. We're going to be a little more specific about our netting, just like we don't normally put dynamic IPs in our automation network. Benefits of NAT, security benefits. It does hide the actual IP address of a device, and there's now no direct communication with those devices. So if I'm going to communicate, if I use a NAT device and I'm going to communicate with that PLC, I'm going to have to pass through that NAT device, which behooves us to make that NAT device capable of incorporating some security. So what is it that's required to perform this simple operation? And we already looked at it, and that is the S615, or a device of that sort, a NAT device, and that's what the S615 is. It's a NAT device. What is different, and we'll cover this in a moment with the S615, is it also is a full security device. So it's a complete, total, stateful firewall. So I can also be firewalled as well as provide NAT access. Something we're not going to cover today, or at least not in any depth, is that the S615 also supports remote connection. So now we can do VPN tunneling as well. So once I've provided the NAT, how do I make the network more secure? Well, ideally, that device would be a firewall. So what I want is my S615 to provide NATing as well as firewall capability to prevent unwanted access into my machine network, and keep that machine network running essentially local and dumb, for instance, to the outside world. So a firewall can be a physical device, can be a software device. The idea is that it's blocking unauthorized, unwanted access to our network, whatever that network happens to be. In this case, it is an automation network. So security benefits. We're blocking unwanted traffic, allows for monitoring, firewall logs, and that's something we'll look at in the S615. We'll turn on the firewall logs and look at the results. Something the 615 also does, it has syslog server capability, or connectivity. So now we could connect to a syslog server, which is really beneficial because your IT systems are currently most likely running syslog servers with syslog message analysis. So that would be very effective as well, something we can combine or work with our IT group. And I do want to stress, when it comes to IT, our traditional approach, engineering and IT, do not necessarily get along, Hatfield-McCoy. However, I think that's a thing we have to get away from. We need to start incorporating IT into our designs early, and the earlier we do this, the better our results are going to be, because ultimately we are going to use their systems, or at least integrate with their systems. Potentially with the firewall, we have policy enforcement, and we restrict IPs and zones, and we'll look at that a little bit as well. Something I wanted to cover is subnetting, but I'm not going to cover that in great depth. However, the presentation for today, I've added the addendums that talk about subnetting a little bit, as well as some other topics like VLAN routing and VLANs, and explain those a little better. So I'm not going through all of those slides. However, they are in the presentation on the back end. So firewall types, and two basic types, stateless and stateful. A stateless firewall is essentially looking at each piece of the packet, so to speak, each network frame, treats each one individually. The disadvantage of that is it does not understand when this is part of a larger connection, or when a device is trying to establish a connection, which is why the stateful firewall is typically preferred. And that is what we have with the S615, is a stateful, which will analyze the traffic in light of connections from start to end. So with that, I'm going to switch to an actual project. So what I'm running is TIA portal, and this TIA portal is Siemens software to program Siemens PLCs, Siemens HMIs, Siemens networks. I'm just going to demonstrate going online with the PLC initially. So right now my PLC's address is at 192.168.1.15. My PC is also in that subnet, so I'm essentially just connected locally to this machine. The IP address of my node, I have a distributed I/O node, is at 1.25, and the HMI is at a 1.16. Now these guys are configured such that I have a web server enabled on the HMI, and I have a web server enabled on the I/O node. Now typically I'm not going to want to get to the I/O node, but I am using that for demonstration today. So here I'm connected locally in my PC. My PC's IP address is also in that 192.168. Well, apparently that isn't the case there. I'm still connected through another device, but we're all in a local connection at this point. So what I'm going to do is switch to connect through my S615. Right now I have a factory reset S615, so I'm going to go ahead and configure that. Okay, so I'll go offline here, and I'm going to open up the web server for the S615. So this is configured from scratch, so this is exactly what you would get when you log into the S615 the first time. It is web configurable. Default IP address is 192.168.1.1. So being a security device, it's not going to allow the default password. So I'm going to change that. And this should bring us to our start page, actually the basic wizard to set this device up. So 615 is designed to route between networks. So the internal network is at VLAN 1, that's 192.168.1.1. It can communicate with all of those devices. What I'm going to do now is take the secondary network, or the outside network, and put it out at a different IP address. And this is where I'm going to do a little bit of subnetting to create a little more security. So this subnet, and you can Google this if you'd like, just do a subnet calculator. This is also explained later in the presentation. I felt like we would go over if we got too deep into that. What this subnet does is eliminates a large network. So instead of being that 172.16.10.30, normally, the way we would see these, that would communicate with up to 254 devices. So for instance, if I look at the subnet mask on this first address, 192.168.1.1, with this subnet mask I can communicate, this IP can communicate with any address between 192.168.1.1 and 255, 1.255. 255 is the broadcast address, so typically it's going to be 1 to 254. So that's a lot of potential PCs that can communicate on that network, or devices. So down here on this network, or I should say out on the VLAN, the outer network, I've shortened this subnet. So now the network, the .30 is part of a network that can only communicate between 172.16.10.0 through 31, with the valid addresses really being 1 to 30. So that's eliminated the total number of PCs or devices that can get to this side of my routing device. So it's just another measure, another independent layer to add, and that's what we would call IP subnetting. You can connect to a network time server, of course, from the 615. That's helpful for log messages, really the date timestamp for the messages. Send a remote connect, I'm not going to enable at this point. That is where I actually provide remote access. And it does utilize OpenVPN. So now we'll set values, and this will bring me to my start page. So this is the way the front of the device looks. Top port is port 5. That's by default connected to VLAN 2 or the outer network. And then we connect ports 1 through 4, essentially serve as a local switch on the local area network side, or VLAN 1. So the first thing I'm going to do on the device is I'll go ahead and write this configuration. So the first thing I want to do on the device is turn off the firewall. And the reason I do that is I'm about to set up some NAT rules. And when I set up those NAT rules, I don't want my firewall also causing me problems. So I want to make sure my NAT is working. I don't want to troubleshoot two things at once. Once I have the NAT working, I'm then going to add in the firewall. So the firewall is disabled. I'll make sure that's set. And then the NAT function is at an NAT, network address translation. That is at a layer 3, because we're translating IPs, which reside at layer 3. So that's a layer 3 function. We're going to move over to the netmap function, which is the S615's version of NAT. And this recording will help if you want to walk back through this on the recording. That'll work. And as we set these up, or you have an application set one up, certainly contact us, because there is a little bit of mental gyration you have to work through to make sure you're setting it up correctly. I have two different types of NAT, source destination here. I'm choosing destination because the IP address that I'm going to be NATing or virtualizing is the one that I am trying to reach from VLAN 2. So VLAN 2 is going to try to get to VLAN 1. The other benefit to the destination NAT is that it processes through the firewall. So the firewall happens after the NAT, and we do get our firewall protection. So the source IP subnet is my PC. Now my PC is going to be at, I'm going to place this at actually 28. But what I want to do instead is open up a range of PCs. So this way, maybe I have up to 30 PCs. That's a decent size range to start. And what I've done is created a 27-bit subnet mask, which is the same as the one I configured earlier, the 255.255.255.224. And that's going to say, by creating this network, it's going to say that any device between 172.16.10.1 through 31 will be able to utilize this netmap and will be translated through or connected to the translated. The destination subnet is the one that I'm creating. So this is going to be what I would call the virtual IP address of my PLC. Now my PLC is at 192, and I'll revisit that, 192.168.1.15. And what I want to do is create a NAT address for this PLC up on the upper network, which is 172.16.10.15. The /32 means that is going to be a one address network. So that means only that IP address is going to be translated, or it's going to be one IP address only that gets translated to. What is the IP address from the standpoint of the source that we're translating to? When we connect to this IP, what are we trying to get to? Well, we're trying to get to that 1.15, and we're trying to get to only that 1.15. So again, I'll make that a 32-bit subnet mask. Create, and now my NATing is enabled for me to get to that address, the one at 170 or the one at 192.168.1.15. Right now, I'm still on the local side of the S615. So I'm still down here in these bottom 4 ports on the local side, and I'm connected up here at 192.168.1.1. Once I finish this NATing operation, then I'm going to switch to the other side as if I was on the plant network. So here's the first one. Now I'm going to create a second one. Source IP again, same story. What I'm going to create this time as a way to get to my HMI's web server. So I want to be able to get to the HMI. Well, I could download to the HMI as well. I just want to get to the HMI. So the same story. I'm going to give the same range of IP addresses the ability to get to the NAT address. So this time I'm going to take the HMI and put him at .16. Now I could take an entire range from the 192 band and just translate up all 31 addresses if I wanted. So that's a possibility also, but in this case I'm really just specifying one at a time. It gives me just a little bit more security on that side of the network because I don't necessarily want all of those addresses. I just want those the HMI PLC, and I'm going to add in the Turk node as well. So again, one device, one address, and there's my second NAT. Now I'm going to add in one more, and that is for the Turk device. And I may not normally do this, but this is just for demonstration. So now I've added in the Turk, which is going to translate up to 172.16.10.25. So all three of those NATs are now created. I'm going to go ahead and write the startup config, so now that's actually active. I'm going to physically change my connection. So I'm going to connect my PC now to the wide area side, or the VLAN 2 side of my S615. Okay, so I'm on the 172 side. So now if I were to try and access ping my 615 at the 1.1, you'll notice it's no longer accessible. So I'm going to change my address to be on the 172 side. And I'll keep the subnet identical. So you'll notice I also lost connection to the web server at 1.1. So now if I ping the 615, at the 172 address, I can communicate with it. So I'll go ahead and change this address now. Forgot to change password. So now I'm back in to this guy. So how do I get online with the PLC? Well, with Siemens, we have an ability, so we're really not communicating any longer directly with the 192.168.1.15. We have an ability within our online access to change the path. So even though I'm really trying to get to 1.15, I'm going to set this access address to be this new address, 172.16.10.15. And that's letting the software know that's how we're really getting to the PLC. However, other software, if they did not support a feature like this, you'd simply have to change your IP to this range on your actual device. So now we'll go online, and it's now actually connecting through the S615 and the natting operation. So we should see that we go online, and we do have a block of logic here. Connecting to a banner smart light. I'll go ahead and connect to the IP address of the Turk node. So here I've connected to the Turk node at 172.16.10.25, but notice the actual IP address is still 1.25. So from the Turk standpoint, it is receiving packets from a network outside of the 1.25, but it's sending it to the gateway, which is our S615, which is making sure we're getting to the Turk device at this IP. The Siemens web server, I use a utility smart client, but you can also use a web browser. And I'll go ahead and connect. There we go. There's the HMI. And just as a quick test, you can see we're in manual mode. Here we are in manual mode or not automatic mode. Make my change, and we're in automatic. So we're now communicating remotely across our network through the S615, and we have some layer of security in that we don't have direct access to the 192 network. We're only accessing the addresses that we've made available. So we do have some access here. So what I'm going to do, now that we have the NAT operation working, now let's turn on the firewall and actually get some protection, or some decent protection. So with the firewall, I'm going to go ahead and configure the things that I want to allow through. I use a principle I would call implicit deny, meaning I'm going to turn on the firewall, block pretty much everything, and only allow through what I want to get through. So before I activate the firewall, I'm going to go ahead and configure some rules. One thing that the 615 does that I like, to give you some predefined IPv4s. In the past, when I've had to do these devices, we've had to actually know the ports and the services that we want to turn on and off, such as ping, but it gives you a handful of the most useful that you want to allow or not allow. So you'll notice on VLAN 1, which is the machine side of the network, we're allowing a ping, but on VLAN 2, we're not going to allow it. So that means, even though right now I can ping a PLC successfully at the new address, I can also ping the HMI at the new address, and I can ping the Turk node. When I get done with the firewall, I'm not going to be able to ping those devices, even though I'm going to allow connection to those devices. So that gives us more security. Someone with a ping scanner would not likely be able to see our devices. Normally, I'm not allowing access to the S615 over HTTP or HTTPS, meaning I cannot configure its web server once I turn the firewall on. In our case, I'm going to leave it on so that I can see it. But in most cases, you might leave that off so that someone on the VLAN 2 side of the S615 could not get into the web server and configure it. Now what I have to do is create an IP service, and this does require some knowledge of what I want to get through. So for instance, if I wanted to connect to a Rockwell PLC via RS links, I would need to open up TCP port 44818. For a Siemens PLC, it's TCP 102. So I'm just naming it TCP 102. The Internet Authority on Numbers, IANA, specifies that our PC is going to be given a port in the upper port range. So I'm going to give that a range that will be encompassing of my PC, but on the destination port, I want to get to port 102. So this is an IP service, and I'm going to then configure an IP rule that says I want to allow or disallow that service for a particular device. So we're now going to open up create a service for our HMI. Our HMI actually uses a service called VNC. VNC uses TCP again, but the VNC port is 5900. And then one more service says I'm going to allow the access to that Turk's web server, and that is going to be HTTP traffic, which is going to use TCP port 80. So there are my three services that I'm going to choose to allow to get through, and only these three essentially, along with what I've predefined here. So now I select IP rules, and this is where I'm going to specify what I allow through based upon those services. So I create a rule where I'm going to accept packets from VLAN 2 to VLAN 1. The source IP is again that same range I've been working with. So that's that 172.16.10.0 through 31. And the destination is going to be my PLC in this case, and only my PLC. I could allow all services, but instead I want to limit to only TCP 102. And additionally, I want to create a little log that lets me know when that's been accessed. So now anytime I do this, this will be part of my log, which is built into my 615 or could be incorporated with syslog. So there's the first rule. I'll add a second rule for the HMI's web server. So the HMI is at 1.16, and again, I'm going to pick specifically that VNC service that I created. And then the final one, I'm going to allow the Turk node. In fact, before I do that, just as a proof, I'm going to go ahead and just leave these two rules in initially. And I did not enable the firewall, so let's go ahead and enable firewall. So now those rules are active and true once I write the config. So just as a test, this was the gateway that I was getting to before, the Turk gateway. If I attempt to get to that gateway now, because I've not set up a rule, you'll notice it's not going to load the page. So I'll go ahead while that's loading and I'll switch to the PLC. I should still be able to get online with the PLC. And one thing I'll show you is, and I mentioned it earlier, what the scan looks like if I use a tool called InMap, for instance. What the scan would look like of an open of the same NATing operation with and without the firewall. It's pretty interesting. So here I'm going to go online with the PLC, so I'm back online like I was prior to setting up the firewall. But even though I'm online, you'll notice now that even though I could ping the PLC, now at that same IP address I cannot ping the PLC because I'm blocking that. I'm blocking most everything to the PLC. Just TCP 102 is getting through, and you can see I am online with my PLC and monitoring traffic. If I look back in, you can see my Turk device did not load. And if I look in my information on the S615, look at the log table, firewall log, here we can see this is where my PC has accessed the PLC at TCP port 102. So now I have information that tells me I did get through. I'm going to go ahead and now add the Turk device in. VLAN 2 to 1. And I want to get to, again, the same device. 1.25 at 32, and specifically I want to allow TCP port 80 and only TCP port 80. Set the values, write the startup config, and now when I go to the same IP address that I could not reach, I'm able to get there. And again, I'm at 10.25, really getting to 1.25. That's the NATing operation. But the firewall has prevented even the ability to ping the Turk device. So the only thing it's letting through is TCP port 80. So now I'll go ahead and get back online with the HMI as well. Here we are, I'm in auto mode. Oh, I knocked my PLC offline there when I wrote the configuration of the S615 again. Good point too, the 615, something I would recommend. The 615 is C-plug capable, meaning you can add a memory plug to the 615 that will allow you to store its configuration, so that if you did have the 615 fail, which of course they only fail on third shift, but if it did fail, you could simply plug in the C-plug, pull it out of the first 615, put it into the second, and not have to deal with any configuration at all, which is obviously advantageous when we're dealing with a network that we want to keep running as long as we can. Minimize downtime. So now I'll be back online with PLC. I'm already online with the HMI, and I can ping none of these devices now. So here we go, I'm in automatic mode. Put it in manual mode, and there you can see my state changed. So we're connected through NAT, through the S615, and we're also firewalled. So I have protection on the firewall side, and a practical example of that firewall, I ran a scan with what we call InMap, utility free download, which is really, you use it for vulnerability testing, but obviously bad actors would not use it for such. And when I ran this utility without firewall, just ran a scan on all TCP ports, it is almost startling the information that I got. TCP port 102 is open. The hardware, it gives me exact part number, and of course MAC address as well. So now if I know what that means, which again, this is where the merging of the knowledge base is a little startling for us. Now, if, as a controls person, I see this and I know what that means, I can open up TIA portal and I can start downloading to that PLC depending on its protection level. I could upload from that PLC, gain its code, maybe make small modifications. So all of a sudden I have a potential risk here because I could reach this PLC. The InMap tool reported all of the NATed IP addresses here. So there's the PLC, the HMI, the Turk node, all of the things that I NATed through it could get to, and the ports that were open it discovered. So that is, again, a little startling. So what I did afterwards, after turning on the firewall, is I ran the tool again. And we'll take a look at the difference. I can get the screenshot to show. Here we go. Oh, that's the one you already saw. Here we go. So this is after turning on the firewall. So at this point, it does not know the device type. It could discover the MAC, and that's as far as it could get. This message here, all 65,535 ports are filtered. What that means is they're firewalled. It does not know whether those ports are open or closed, whether they're available or not available. So that's a pretty significant protection. So now at this point, as a controls person, I really don't know what that device is, and if I could get to it and do anything to it at all, that port has been blocked. So that's a typical example of what you would see from a firewall, and I'm probably going to, if I'm on a bad guy or a black hat hacker, I'm probably moving on to an easier target. So that was the presentation for today. Just a simple demonstration of how we can add one security device that will make a difference, a significant difference, in how we access our machines and do it securely. The beauty of implementing something like an S615 is that I can add that to an older system as well. I could add that to a SLC 505. I could add that to a Siemens S7300 PLC. I would not have to add a separate Ethernet module, and I could still bring up any particular device that was Ethernet based, such as an HMI or a web server on a device. I could bring that up and access it, and then set up the rules for that access so that only what I want to get through can get through. If you do have a security question or you're interested in a solution like this, contact your local salesperson at C&E, and we'll be happy to help set this up, help work through the application with you, teach you how to do this so that you can implement this throughout your facility or on other machines as well. Check, we have questions. I don't see them at the moment. I appreciate you attending today. And if there are any questions, feel free to fire away.
Jeff, thank you. Very nice presentation. As you mentioned, I don't see any questions, and we'll wait just a minute and see if anybody wants to submit one. As Jeff mentioned, if you have applications where you need some assistance, such as with network protection, get with your local salesman, and he can coordinate with his automation specialist and come out and talk to you about it. We also have other specialists in other disciplines that can come out and take a look at your various applications as well, such as motion control and machine safeguarding and vision and so forth. Jeff, we had a question come in. Do you see the question block there?
Yeah, let's see here. Yeah, for some reason it's a little shrunken here. Let's see if I can get it.
I can read it to you if you'd like.
There we go. Okay, can Firewall Office into the module E1 cozy for allowing an OEM to remote into a machine? Yeah, the question is, can the firewall block CCMIA M2M module or E1 cozy from allowing an OEM remote into the machine? It could. It could. One, if you notice, depending on where it's located. So if you look at the firewall settings here, for instance, we're going to eliminate IPsec, but we could also prevent any of the ports associated with OpenVPN, which would be potentially TCP port 443 or UDP 1194. We would have to allow that. So if we turn this firewall on, again, this is what I call implicit deny. We could deselect all of these if we wanted, although these would not prevent us necessarily from allowing the CCME or E1. But if I come over here to IP services, I would actually have to open up a port specifically for that device to get through. That's assuming I put the E1 cozy or the CCME on the VLAN 2 side of the S615. So this VLAN 2 in this case, now I can change which ports get to which VLANs, but VLAN 2 in this case is this upper level port that's at the 172 network. So if my CCME device were on that network, then I could not get to it unless I open it up. If the CCME or cozy device were on this lower level network, assuming it had actual internet access, it would still get to it with no difference. It would not have any firewall protection at all at that point. So hopefully that answers the question. Another question, is the 615 just came in, is the 615 available with wireless access? No, the S615 is not. However, we do have another product that would do pretty much the same thing or similar, and that would be, well, actually, we'd probably combine those two. An M874 device from Siemens that's cellular-based, and it is a Verizon cellular, and we could combine that with the S15 to provide the security function or even remote access at that point. And in that case, we would likely combine it with Cinema Remote Connect, which is a software that you would get with your remote access device. And it would allow you to configure user groups, who can get to what device, etc. That was good. Hopefully that answered those questions. Any others?
Thank you all for the questions. Thank you for joining us today to hear what Jeff had to say about this subject. We certainly appreciate it. Another question came in, Jeff. I can answer this one. Can you share the presentation or video capture? Yes, we can. Actually, everybody who attended the webinar today or was registered for the webinar will receive a link. We'll take it. It should be posted to our website probably this afternoon or tomorrow morning. So you'll get a link to that.
And as I mentioned in the presentation, I did add an addendum that covers some of the subjects I referenced, such as IP addressing and how we do some subnetting, as well as VLAN routing and VLANs. So there's a little more information in the presentation you'll get on the back end of the presentation we looked at today.
Very good. Jeff, thank you. Thanks to everyone in attendance.